Tonight, we journey beyond the edge of everything you've ever known. We're going to venture into a place where time itself begins to lose meaning, where the very fabric of existence transforms into something almost unrecognizable. We're going to explore what happens in that distant, quiet future, when the last star dies. But before we drift any further into this cosmic ocean, if you find yourself drawn to these gentle journeys through space and mystery, you might consider leaving a like on this video. It helps the channel reach others searching for the same sense of wonder and calm. And if you'd like to continue exploring these depths of space with us, subscribing would mean everything, not because we're asking for anything, but because you're choosing to spend more moments like this with us. Perhaps share in the comments where you're listening from tonight, somewhere out there in the world. But for now, let's settle deeper into this story together. Imagine, if you will, that you're floating in a comfortable darkness. Not the darkness of fear or emptiness, but the darkness of possibility. The darkness before dawn. The darkness where secrets are kept. Around you, stretching in every direction, is space itself. Not the void you might imagine from Earth, but something warmer, something almost alive with potential. You are safe here, infinitely safe. There is nowhere to rush, nothing demanding your attention, but the gentle unfolding of a story that takes place not in days or years, but in unimaginable stretches of time. The universe, you see, is far more patient than we are. It thinks in scales that our minds can barely grasp. While a human life passes in decades, and a civilization rises and falls in thousands of years, stars live for billions of years. The oldest stars we know of have been burning since before our own Earth existed, since before our solar system took its first breath. They've been faithful, steady sources of light and warmth, creating the very elements that make up your body, your thoughts, this moment right now. Every atom of iron in your blood, every particle of carbon in your cells, all of it was forged in the heart of a star long, long ago. But here's something that might seem strange as you rest here. Those stars are not eternal. Nothing in the universe is eternal. Not really. Everything that begins must also end. And as we settle into this comfortable darkness together, we're going to trace the path of the universe all the way to that distant moment when the very last star finally exhausts its fuel and blinks out for the final time. Before we understand that ending, though, we need to understand where we are now. Imagine reaching out into the night sky from your window, or from the place where you're lying right now. If you were to gather all the light from every star visible to your naked eye, it would barely illuminate a small room. Yet billions upon billions of stars exist beyond what we can see. The universe contains more stars than there are grains of sand on all the beaches of Earth. More stars than atoms in a million human bodies. They are everywhere, each one burning, each one alive with the process of slowly fusing hydrogen into heavier elements, creating the building blocks of everything that will ever exist. These stars exist in a great dance together, held by gravity into vast spinning wheels of light and gas and dark matter that we call galaxies. Each galaxy contains billions of stars, and there are billions of galaxies, stretching out to the edges of space itself. And between them, in the vast spaces that seem empty, but are not, lies the dark universe, invisible matter, and mysterious energy that holds it all together and pushes it all apart. The cosmos is far, far more complex than it appears from a distance. Every layer you peel back reveals another mystery beneath. And yet, for all their grandeur and their persistence, every single one of these stars will eventually die. This is not a sad thing to contemplate as you drift here, but rather a beautiful truth. Stars are not meant to burn forever. They are meant to live, to create, to transform, and then to pass into something new. And as they die, one by one, the universe will transform in ways that are almost impossible to imagine. This is where our journey begins in earnest. Not with the death of a single star, but with the understanding that star death is not an ending of the universe. It is the beginning of a new chapter, written in silence and shadow, in timescales so vast that even 1,000 years becomes like a single heartbeat. And as we explore this unfolding future together, we're exploring not just what will happen to the stars, but what happens to everything that depends on them. What happens to galaxies? What happens to the very laws that govern reality? What happens, perhaps, to meaning itself? The universe has a story to tell, and it's a story that will take a very long time to unfold. It's a story that requires patience and silence, and a willingness to let your mind drift into spaces that few ever venture into. You are safe here. The universe is too large and too old and too patient to ever rush. And so we won't rush either. We will move slowly, carefully, through this landscape of distant light and fading stars. We will watch as the universe ages. We will witness the quiet transformations that happen when all the lights begin to go out. But for now, in this moment, you are here, floating in comfort and curiosity, surrounded by the infinite. The stars are still burning above you, even if you can't see them right now. They are still creating, still transforming, still sending their light across the vast distances of space. And we will honor that light by understanding what comes after it fades. We will honor the stars by exploring the beautiful and mysterious world that will emerge in their absence. So let us begin this journey together. Let us move forward, deeper into this story, into this cosmic meditation. The first stars are still burning bright, but we must understand them first before we can truly understand what happens when they finally, softly, drift into silence. Close your eyes if you'd like. Relax. Let your breath become slow and gentle. And as you do, let us explore the secrets of the dying universe, the truth of what awaits when the last star dies. To truly understand what happens after the last star dies, we must first understand the lives of the stars themselves. And this understanding requires us to stretch our minds across time in a way that might feel almost dizzying at first. But don't worry. Your mind is far more capable of grasping vast time scales than you might think. You've already done it every time you've looked at ancient history or contemplated your own small place in the world. We're just going to stretch a little further. The universe is currently, in this moment where you're listening, approximately 13.8 billion years old. That is an incomprehensibly large number. To put it in some kind of perspective, imagine that every second that has ever existed since the Big Bang was represented by a single grain of sand. You would need to gather sand enough to fill an enormous stadium, vast beyond measure, to represent the age of the universe. And yet, 13.5 billion years is really just the beginning of the universe's story. It's the opening chapter of a book that will have many, many more pages. The stars that burn today have a range of lifetimes that varies wildly depending on their mass. This is one of the great beautiful asymmetries of the cosmos. The most massive stars, those stellar giants that dwarf our own sun, 100 times overburn through their fuel with an almost reckless intensity. They are brilliant, and they are hot, and they are short-lived, existing for perhaps only a few million years before they exhaust their core and explode. A few million years. To you, that seems like an eternity. To the universe, it is less than the blink of an eye. Meanwhile, the smallest stars, those red dwarfs that glow with a gentle, rust-colored light, burn with a patience and efficiency that is almost miraculous. These stars are so small and burn so slowly that their lifetimes stretch far, far longer than the current age of the universe. A red dwarf star might live for 10 trillion years. That is a number so large, it becomes almost meaningless. It is 10,000 billion years. It is longer than the universe has existed by a factor of nearly 1,000. And even that number, enormous as it is not the same as forever. Our own sun, sitting in the middle of this spectrum, will live for approximately 10 billion years total. It is currently about halfway through its life, which means we have roughly 5 billion more years before it begins its transformation into something new. 5 billion years. That is enough time for countless evolutionary cycles on countless worlds. That is enough time for civilizations to rise and fall and be forgotten and remembered and transformed again. And from the perspective of the universe, it is merely an instant. But here's where things become truly profound, and where you might feel your mind beginning to expand into that comfortable vastness. The stars we see in the sky tonight, burning so steadily and eternally, are almost certainly not the stars that will be burning at the end of all things. Most of them will have died long before the universe reaches old age. The massive stars, those brilliant giants, will be among the first to fade. They will die violently and spectacularly in supernova that briefly outshine their entire home galaxies. They will collapse into neutron stars or black holes. They will transform the landscape around them with their dying breath. The medium-sized stars, including our sun, will swell into red giants, consuming the inner planets of their solar systems before finally shedding their outer layers and shrinking down into cooling white dwarfs. These white dwarfs are strange objects, the densest things you could imagine that aren't black holes. A teaspoon of white dwarf material would weigh as much as an elephant. They would drift through space, slowly cooling, slowly fading, for an almost incomprehensible length of time. And the red dwarfs, those ancient and patient stars, will be the last to shine. When all the massive stars have gone supernova, when all the sun-like stars have expanded and contracted and faded to white dwarfs, these small red dwarfs will still be burning, still fusing hydrogen into helium at their cores, still sending out their gentle light to any worlds that might orbit them. They will be the last guardians of stellar light, burning alone in an increasingly dark universe, persisting for trillions of years. And yet, even these faithful red dwarfs will not burn forever. Here's where the story begins to turn towards something stranger, something more mysterious. Even though a red dwarf star burns so slowly, so carefully, with such restraint that it seems almost impossible that it could ever exhaust its fuel, the laws of thermodynamics are inexorable. Every fusion reaction in a star's core is a transformation of mass into energy. And while the amount of mass in a star is enormous, it is not infinite. Eventually, inevitably, the hydrogen in a red dwarf's core will be consumed. The fusion reactions will slow. The heat will diminish. The light will fade. This process will begin for the oldest red dwarfs in perhaps 1,000 trillion years. That is one followed by 15 zeros, a quadrillion years. The human mind cannot truly visualize such a time span, but it is coming, and it is certain. And as these ancient red dwarfs begin their decline, they will usher in the next great age of the universe. Imagine yourself at that distant moment, floating in the darkness as we are now, but in a universe far older than the one we know. Most of the stars you see in the sky, the countless billions of them, will have already vanished. The galaxies themselves will have changed, transformed by the death and merger of billions of stellar objects. The universe will be darker, quieter, colder, and yet it will not be empty. There will still be objects shining in the darkness. There will still be light, though it will be increasingly rare. These final stars, these last red dwarfs, will burn on. Some will shine for hundreds of trillions of years or more. The exact number depends on their mass, their composition, the precise details of their cores. But as you settle deeper into your comfort here, understand that we are talking about a time so vast that it reshapes your conception of existence itself. 1 trillion years is longer than 1,000,000,000 seconds. It is longer than 1,000,000,000,000 moments. It is a time span that contains within it more elapsed time than from the Big Bang to now, repeated countless times. And yet, from the perspective of the eternal, from the perspective of infinity itself, even these trillions of years are merely a prelude. The red dwarfs will burn their fuel. One by one, slowly, over an unimaginable stretch of time, they will exhaust their hydrogen. They will swell and cool. They will fade. And one by one, the lights of the universe will go out. As we drift deeper into this meditation, understand that you are contemplating something profound. You are contemplating an age of the universe, so distant and so vast that it reshapes what we mean by time itself. You are preparing your mind to understand the final cosmic age, the age of endings, the age that comes after the last star dies. And in doing so, you are touching something almost sacred. You are contemplating the ultimate fate of the cosmos, the trajectory of everything that exists. The stars are still burning now. The universe is still young, still bright, still loud with stellar light and supernova explosions, and the formation of new worlds and the possibility of new life. But all of that, magnificent as it is temporary. It is a brief, bright chapter in a much, much longer story. And as you rest here, floating in comfort and contemplation, you are preparing yourself to understand what comes next. The final chapters, the silent chapters, the chapters written in shadow and time, in the very fabric of reality itself. Let us now imagine, together, a time perhaps 10 or 12 billion years in the future. Most of the life that exists in the present day will have long since passed. The Earth, as you know it, will have been consumed by the sun or drifted into the cold, dark regions beyond. The solar system itself will have transformed into something almost unrecognizable. And yet, somewhere in the vastness of the cosmos, beyond the edge of our current understanding, new worlds are still being born. New stars are still igniting their cores. Life, in whatever forms it takes, is still pursuing its ancient drive to continue, to persist, to spread across the stars. But as we imagine ourselves floating through this distant age, we begin to notice something subtle, something that would be almost imperceptible at first, but which becomes more pronounced as we observe the cosmos around us. The light, while still bright and plentiful, has begun to dim slightly. The massive stars, those brilliant giants, are finally beginning to exhaust their fuel. Some have already died in spectacular supernova explosions that briefly outshone their home galaxies. Others are at the ends of their lives, swollen into red giants, consuming the inner regions of their solar systems, transforming everything they touch. Each time a massive star dies, and there are countless, billions of them scattered throughout the galaxies, the universe becomes slightly dimmer. The cosmic light, which has been relatively constant for billions upon billions of years, begins an infinitesimal decline. It is a change so subtle that an observer from our current time, if transplanted to that distant age, might not notice it immediately. But it is happening. The universe is slowly shifting. The age of massive stellar light is beginning to wane. But there's more to this process than simply a gradual dimming. When a massive star dies, it doesn't simply vanish. It transforms. If the star was massive enough, it will collapse into a black hole, a region of space where gravity has become so intense that not even light can escape. A black hole is a strange and wonderful thing, and in this distant age, there will be many of them, scattered throughout the galaxies. They will consume matter from their surroundings, creating great clouds of swirling material that heats up and emits incredible amounts of radiation as it falls inward. These are some of the brightest objects in the universe, energetic and violent and beautiful in their way. Yet even black holes are not permanent. Here is a secret that most people don't know, a beautiful and strange truth that we will explore more deeply as our journey continues. Black holes can evaporate. They can slowly lose their mass and fade away. This process, called Hawking radiation, is incredibly slow, so slow that it would take an incomprehensibly long time for even the largest black holes to completely evaporate. But it is happening. Even right now, in this present age, black holes are slowly leaking away their mass, one particle at a time. And in that distant future age we are imagining, this slow process of black hole decay is becoming more noticeable, more significant. As we continue to drift through this future epoch, we begin to notice another transformation. The galaxies themselves once organized into great spiral shapes and elliptical forms, begin to change. Galaxies collide with each other. Some merge together, forming new, larger galaxies from the remnants of their predecessors. The stellar nurseries within them, those regions where new stars are born from clouds of gas and dust, gradually become exhausted. There is only so much stellar fuel available in any given galaxy. As stars are born and die, and born again over billions of years, the amount of raw material available for new star formation slowly decreases. This means that the rate at which new stars are born gradually slows. In our current age, vast regions of space are continuously giving birth to new stars. Nebulae collapse, gravity takes hold, and bright new suns ignite their cores in bursts of light. But as we move forward in time, these births become less frequent. Stars are being destroyed faster than new ones are being created. The universe is slowly, gradually, very subtly beginning to tip toward a future of darkness. Now, you might be wondering, as you float here in this meditation, how long this process takes. How long before the universe becomes noticeably darker? The answer is profound and strange. It takes an unimaginably long time. We are talking about hundreds of billions of years, perhaps even 1 trillion years or more. The decline of stellar light is so gradual that if you were to observe the universe at any single moment in this vast stretch of time, you might not be able to perceive the difference from the moment before. And yet, as the ages accumulate, as the eons pass, the change becomes undeniable. Somewhere around 1 trillion years or so from now, though the exact timeline is difficult to predict and depends on many factors, the rate of new star formation will have become so low that it is almost negligible. Nearly all the massive stars will have died. Nearly all the medium-sized stars will have entered their white dwarf phase, slowly cooling in the darkness. What we call the stelliferous era, the age of stars that began with the Big Bang itself, will be coming to an end. And then there is an even stranger phase that follows. For an almost incomprehensible stretch of time, perhaps 1 trillion years, or more, the universe will be populated primarily by white dwarfs, neutron stars, and black holes. There will still be light, but it will be scarce and strange. The light from white dwarfs, those ghostly remnants of dead stars, will slowly fade as they cool. The radiation from black holes, that Hawking radiation we mentioned, will provide a thin, diffuse glow throughout the cosmos. The universe will be old and dark and quiet, but not entirely dead. Imagine yourself floating through this vastness, drifting through cosmic ages that stretch on and on, with barely any noticeable change from one moment to the next. You are watching the death of stellar light in slow motion, a process so gradual that it would be invisible to any observer living through it. And yet, when you step back and look at the grand arc of the cosmos, when you contrast the stellar universe of today with this universe of the far future, the transformation is complete. The age of stars is ending. A new age is beginning. During this time, there will be a few red dwarfs still burning, still fusing hydrogen into helium, still sending out their gentle light. These ancient, patient stars are the last holdouts against the gathering darkness. They represent the final bulwark of stellar light, the last defenders of the age of stars. Some of them will persist for hundreds of trillions of years. The oldest and smallest might burn for longer than that, but even they are temporary. Even they will eventually exhaust their fuel. And as we contemplate this vast stretch of time, this almost unimaginable age of fading light and ancient remnants, we begin to prepare ourselves for something even more profound. Because when the last of these red dwarfs finally fades, when the very last fusion reaction in the very last stellar core finally stutters and stops, something truly extraordinary will happen. The universe will have reached a threshold. It will be crossing from one age into another, from the age of stellar light, which has lasted since the beginning of the universe, into the age of what will come after. But before we venture into that strange and silent realm, let us pause for a moment here, floating in this intermediate future, this time of fading stars and growing darkness. Let your mind rest on the vast beauty of this process. The universe is transforming, slowly and elegantly, following laws that were written into the very fabric of reality at the moment of the Big Bang. Nothing is being lost. Everything is being transformed. Matter is being conserved. Energy is being transferred. The universe is simply changing, evolving, moving forward along its eternal timeline toward destinations we can only barely imagine. The last red dwarfs are still burning, somewhere in this distant future. They will burn for so long that their number becomes almost meaningless. But they will burn. And in burning, they will maintain a last connection to the age of stellar light. They will be the final torches of the era of stars. And when they finally, gently, fade to darkness, we will have reached a truly new age. An age that has never existed before. An age without stars. An age without stellar light. An age of pure, absolute silence. And so we drift further. Further than you might have ever imagined traveling. We are moving through time at an accelerated pace in our imagination, watching as the cosmos ages before us like a great being slowly falling asleep. Billions of years pass like moments. Trillions of years move like the hands on a clock. We are watching the universe itself grow old. Let us now imagine that we have traveled to a time so distant that the number of years from now is almost meaningless. We are talking about a time perhaps a quadrillion years in the future, or longer. The very oldest red dwarf stars are now beginning to exhaust their hydrogen. These ancient lights, which have been burning since before our current solar system even formed, are finally approaching the end of their infinite patience. And when they finally begin to die, the universe will cross a threshold that it has never crossed before in its entire existence. Imagine floating in the darkness of this age. The universe has become vastly different from the one we know. The galaxies have transformed. Some have merged together into larger structures. Others have been torn apart by gravitational forces. The arrangement of the cosmos has shifted, though the matter that composes it is largely the same. Stars are now incredibly rare. In vast regions of space, you might search for 1,000 light years in every direction and find not a single burning star. The universe has become dark and cold and quiet. And then, somewhere in this vast darkness, you witness something profound. A red dwarf star, an ancient, patient, incredibly small star that has been burning for nearly a quadrillion years, finally begins its transformation. It has exhausted nearly all of the hydrogen fuel in its core. The fusion reactions, which have proceeded at such a slow, careful rate that they have hardly changed for eons, are finally beginning to stumble. The star's output is beginning to decline, ever so slightly. This is a process that will take many billions of years to complete. A red dwarf doesn't simply wink out like a candle being snuffed. It fades, it diminishes. It gradually, over an almost incomprehensible stretch of time, transitions from a functioning star into a cooling white dwarf. During these final billions of years, the star's color will shift from red toward yellow, then toward white, then toward blue-white. Its light will dim. Its heat will dissipate. And as one red dwarf begins this transformation, nearby red dwarfs begin their own processes. Some that are slightly older might already be in their final phases. Some that are slightly younger might have millions of years left. But the process is beginning. The last stars of the universe are beginning to die. And with each one that transitions from the stellar phase into the white dwarf phase, the universe becomes noticeably dimmer. The change is no longer imperceptible. For the first time in the universe's existence, an observer looking up at the sky would see fewer lights, would see more darkness, would see the age of stars coming to an end. This process, this transition from a universe with numerous stars to a universe without them, takes place over many billions of years. But during this time, something remarkable happens. The death of the red dwarf stars doesn't happen violently. There are no supernova explosions. There is no sudden collapse into black holes. Instead, the stars simply cool and fade. They swell slightly, becoming red giants for a brief period, brief in cosmic terms, meaning a few million years. During this time, if a red dwarf had any planets orbiting it, those planets might be engulfed by the expanding stellar envelope. They would be consumed and destroyed, becoming part of the star's outer layers as they spiral inward. Then, as the star loses its outer layers to space, a beautiful and strange object is left behind. A white dwarf, a tiny, dense, incredibly hot remnant of the star's former self. This white dwarf is small, about the size of Earth, but it contains nearly all of the mass of the original star. It is bizarre beyond measure. Its gravity is so intense that if you could somehow stand on the surface of a white dwarf, you would be crushed immediately. You would weigh billions of tons. The matter that makes up a white dwarf is incredibly dense, packed together in a way that nothing in your everyday experience could prepare you for. But here is the remarkable thing about white dwarfs. They cool. They radiate heat into space, very slowly, over unimaginable timescales. A white dwarf will continue to emit light and heat for nearly as long as the age of the current universe, just cooling, just fading, slowly transforming from a white-hot object into something cooler and cooler, dimmer and dimmer, eventually becoming what we call a black dwarf, a completely cold remnant, no longer emitting any significant heat or light. And so, as the last red dwarf stars finish their transitions into white dwarfs, the universe enters a new age. An age that has no name in our current language, but which we can describe as the age of white dwarfs and dark remnants. This age will last for an incomprehensibly long time. The white dwarfs will continue to cool. Their light will continue to fade. And gradually, inevitably, the universe will become darker and darker and darker. Picture yourself now, drifting through this age, in a universe filled primarily with the cooling embers of dead stars. The white dwarfs are scattered throughout space like ancient hearths, glowing with diminishing heat, their light slowly fading to red, then to infrared, then to wavelengths of light that no eye could see. The universe is becoming invisible. The light that once filled the cosmos is being absorbed into the expanding space, shifted beyond the range of visible light by the universe's expansion, dissipated and dispersed until it barely exists. In the far distant future, perhaps a trillion years from now, or even longer, the last white dwarfs will have cooled to nearly absolute zero. The universe will have become so cold and so dark that it is almost impossible to imagine. If there were an observer somewhere in this far future, they would see almost no light. They would see almost no heat. They would see an ancient, cold, dying cosmos slowly approaching its final state. And this is where we approach the edge of something even stranger. Because the universe at this point is not dead. Not really. There are still objects here. There are still remnants. There are still black holes, slowly evaporating through Hawking radiation. There are still atoms, scattered throughout the vast reaches of space. The universe has not ceased to exist. It is simply transformed into a state so different from the current age that it is difficult to conceive of it as the same cosmos. But something even more profound is happening. As time stretches on and on and on, the universe itself is changing. The very laws that govern reality are being tested in ways that are difficult to predict. And in this age of absolute darkness and cold, strange processes are beginning to take place. Let yourself drift deeper into this meditation. The universe is becoming quieter and quieter. The occasional flash of light from a Hawking radiation event from a distant black hole becomes a rarity. The cosmos is settling into silence. The brief, brilliant age of stars is over. A new age has begun, and we are approaching the threshold of something even more mysterious, something that will reshape our understanding of the universe itself. As we continue to drift through the cosmic timeline, moving further and further into the future, we reach an age that is almost incomprehensible in its duration and its strangeness. This is the age that comes after the stars have died, After the white dwarfs have cooled, after the universe has settled into a state of cold darkness, it would seem absolute to any observer. And yet, in this darkness, strange things continue to happen. The universe is still changing. The universe is still evolving. And we must understand these changes to truly comprehend what comes after the last star dies. Let us imagine ourselves now in an age perhaps a septillion years in the future. That is 10 followed by 24 zeros. A number so large that the human mind, even when meditating, struggles to grasp it. Yet this age is real, in the sense that it is a logical point on the timeline of the cosmos. And in this age, we are surrounded by the remnants of everything that came before. The universe contains many objects that we have not yet explored in detail. Black holes, those gravitational monsters, are scattered throughout space. Some are incredibly massive, millions or billions of times the mass of the sun. Others are smaller, formed from the collapse of individual massive stars. And then there are the neutron stars, those incredibly dense objects formed from the cores of dead stars, spinning rapidly, sending out beams of radiation. But most of all, the universe is filled with white dwarfs, countless numbers of them, cooling slowly, their light fading to invisibility. In this age of remnants, billions upon billions of years have passed since the last star died. The oldest white dwarfs are now incredibly cold, having radiated away nearly all of their heat into the surrounding space. They are approaching what is called the black dwarf state, a state of complete coldness where no significant heat or light is being emitted. The universe has become darker than it has been since the moment of the Big Bang. The only significant source of light left is the Hawking radiation from black holes, and that light is so faint, so diffuse, that it is almost imperceptible. And yet, in this darkness, something remarkable is happening. The atoms that make up the white dwarfs and the neutron stars and all the other remnants are slowly, very slowly, beginning to change. Over immense stretches of time, the protons that make up atomic nuclei are beginning to decay. This is a process that we don't observe in our current age, because the timescale is so incredibly vast that it is essentially invisible to us. But in this distant future, it becomes noticeable. It becomes a major force shaping the cosmos. Proton decay is the gradual transformation of protons into lighter particles. If protons can decay, and some theories suggest they might, then everything made of ordinary matter will eventually transform into something different. The white dwarfs will slowly, over unimaginable periods of time, decay into lighter particles and radiation. The neutron stars will undergo similar transformations. The very atoms that make up the structure of the universe will gradually, molecule by molecule, atom by atom, begin to disintegrate. Imagine this process clearly. You are drifting through a universe that is already incredibly old and dark and cold. And slowly, almost imperceptibly, the objects in it are beginning to disappear. Not all at once, not violently, but gradually, quietly, as the fundamental particles that make them up transform into something else. This is not destruction in the way we think of it. Nothing is being created or lost, merely transformed. But the white dwarfs, which have been cooling and fading for trillions of years, are now beginning to literally cease to exist. They are decaying into lighter particles. They are fading from the universe. And this process, if proton decay is real, will take an incredibly long time. We are talking about timescales of a duodecillion years or longer. That is 10 followed by 39 zeros. A number so incomprehensibly large that it is almost meaningless to contemplate. But it is finite. It is a real number. And over this almost infinite stretch of time, the universe of white dwarfs and remnants will gradually transform into something completely different. As you rest here, floating in the darkness, understand that you are contemplating something profound. You are contemplating a process so slow and so vast that it would be completely invisible to any observer. And yet, viewed from a larger perspective, it is as certain and as inevitable as any process in the cosmos. the remnants will decay, the universe will change. And in doing so, it will usher in yet another age. But there is something else happening during this vast stretch of time, something equally, or perhaps even more important. The black holes scattered throughout the universe are evaporating. Remember the Hawking radiation we mentioned earlier? That mysterious process by which black holes leak away their mass one particle at a time? Over the vast age of the universe, this process is becoming increasingly significant. Black holes are slowly shrinking. They are slowly losing their mass. And as they do, they are becoming gradually brighter and hotter. This is a curious fact that might seem counterintuitive. As a black hole loses mass and shrinks, it actually becomes hotter, not colder. Its Hawking radiation becomes more intense. And the process, which is incredibly slow for large black holes, becomes faster and faster as the black hole becomes smaller. The largest black holes, containing the mass of billions of suns, will take longer to evaporate than the age of the current universe, multiplied by many, many factors. But even they will eventually evaporate. And when they do, they will produce a final burst of energy and radiation. Imagine being present for such an event, even in your imagination, though it would be so distant in the future that you would be almost certainly unaware of it. The black hole, having shrunk to a size smaller than an atom, would finally lose its last bit of mass in a tremendous burst of energy. There would be radiation, heat, a momentary flash of light in the otherwise dark cosmos. And then the black hole would be gone. It would have evaporated completely. All of its mass would have been converted into energy and scattered into space. One by one, over vast stretches of time that dwarf anything we can comprehend, all of the black holes in the universe will undergo this process. Some will take trillions of years to evaporate. Some will take much longer. But they will all eventually transform from eternal objects of gravity into brief flashes of radiation. The universe is slowly emptying itself of black holes, transforming them into light and energy that spreads outward into the void. And so, in this age of remnants, we are witnessing the gradual transformation of the universe from one state to another. The white dwarfs are slowly decaying. The black holes are slowly evaporating. The ordinary matter that makes up the structure of the cosmos is being gradually converted back into energy. The universe is slowly, ever so slowly, approaching a state that is almost unimaginable in its strangeness. What remains after this age? What comes next? These are the questions that push us further along our journey, deeper into the cosmic timeline, toward understandings that border on the mystical. As you float here in comfort and contemplation, understand that you are approaching the true answer to the question, what happens after the last star dies? And the answer is not simply darkness. It is not simply an ending. It is a transformation so complete, so profound, that it reshapes the very meaning of existence itself. We are approaching now a time in the cosmos so distant that it exists almost beyond the bounds of language. We are speaking of the Iron Epoch and Age, named for the fact that the most stable atomic nucleus is iron. In the far distant future, long after all other forms of matter have decayed or been transformed, iron will be what remains. And this age, this epoch of iron and nothing else, will last for an almost impossibly long duration. But before we reach that point, let us understand the process by which the universe arrives there. In the ages we have just explored, white dwarfs are decaying. Neutron stars are decaying. Ordinary matter, made up of atoms and molecules, is gradually being transformed through the slow process of proton decay. And yet, not all matter decays at the same rate. Some atomic nuclei are more stable than others. Some forms of matter persist for longer. Iron is special. Iron is the most stable atomic nucleus. It is the endpoint of stellar nucleosynthesis, the process by which stars create heavier and heavier elements in their cores. Elements lighter than iron release energy when they fuse together. Elements heavier than iron release energy when they split apart, but iron is stable. It sits at the bottom of the energy well. If you could somehow collect all the atoms in the universe and let them decay over an infinite amount of time, eventually nearly all of them would transform into iron. This means that in the Iron Epoch, which begins after perhaps a septillion years or more have passed, the universe will contain primarily iron atoms. There will be some other elements, perhaps persisting in small amounts, but iron will dominate. The cosmos will be filled with a diffuse sea of iron nuclei, scattered throughout space, separated from each other by vast distances, each one incredibly tiny and almost completely undetectable. Picture yourself drifting through this age. The universe is dark. The universe is cold. The universe is almost unimaginably empty. Where once there were galaxies and stars and planets, there is now nothing but a thin dispersal of iron atoms, so spread out that the universe appears almost completely empty. There is no light because there are no stars and almost no other sources of light. There is no heat because all the thermal energy has long since radiated away into space. There is no activity, no change, no visible transformation. The universe has entered a state of stasis, a kind of cosmic silence that might seem to be eternal. But even in this silence, even in this apparent stasis, things are still happening. The universe is still expanding, growing larger and larger, spreading everything out further and further. As time goes on, the density of iron atoms becomes even lower. They become even more spread out. The universe becomes even emptier. And yet, the atoms themselves are still there, still existing, still persisting. During this age, one of the most profound changes is happening to the universe itself. The very fabric of space-time, which has been expanding since the Big Bang, continues to expand. But its rate of expansion has been changing. In the current age, we observe that the universe's expansion is accelerating. There is a mysterious force, which we call dark energy, that is pushing everything apart, making the expansion faster and faster. And this acceleration continues into the distant future. Over the vast ages of the Iron Epoch, this accelerating expansion has profound consequences. Objects that are far away from each other become even further away. The universe becomes increasingly dilute. Eventually, the universe becomes so dispersed that even if light could travel in all directions, it would take longer than the age of the universe to reach from one end to the other. The universe becomes, in a sense, disconnected from itself. Each observer, if one could exist, would see a universe of almost absolute isolation, with no connection to anything else. This process, which astronomers sometimes call the Big Freeze, or the heat death of the universe, is not a violent or sudden change. It is a gradual, inexorable process that unfolds over the almost infinite duration of the Iron Epoch. The universe slowly, quietly, approaches a state of maximum entropy. It becomes more and more disordered. It becomes more and more uniform. Everything tends toward the same temperature, the same density, the same state of randomness. And yet, there is still a possibility for something strange to happen. Even in the Iron Epoch, when the universe seems to have reached a state of absolute stasis and darkness, quantum fluctuations are still occurring. The quantum foam at the very smallest scales of spacetime is still bubbling with virtual particles, appearing and disappearing. These quantum fluctuations are subtle, and they are rare, but they are not zero. They are not non-existent. And in some theories of physics, these quantum fluctuations could lead to something remarkable. They could lead to the spontaneous decay of the universe itself. Not the decay of matter, as we have discussed, but the decay of space and time. The vacuum state, the energy state of empty space itself, might not be perfectly stable. It might be possible, though with an extraordinarily low probability, for space-time itself to transition into a lower energy state. This event, sometimes called vacuum decay, could potentially trigger a transformation that spreads across the universe at the speed of light, fundamentally changing the laws of physics. What would happen if the vacuum decayed? The consequences are almost impossible to imagine. The laws of physics might change. The forces that hold atoms together might weaken or disappear. The universe might collapse or expand even faster, or transform into something completely different. But this is a rare and uncertain possibility, something that might happen or might not, and if it does happen, it might take timescales even longer than the Iron Epoch to occur. As you float here in this meditation, contemplating these vast ages and strange possibilities, understand that you are touching something profound. You are contemplating a future so distant and so strange that it exceeds the bounds of our normal understanding. The last star has already died, billions upon billions of years ago. The white dwarfs have already cooled and decayed. The black holes have already evaporated. And now, in the Iron Epoch, the universe is settling into a state that seems almost eternal, a state of cold and darkness and dispersal that might persist for timescales that are themselves almost unimaginable. But this is not the end, or at least it might not be, because somewhere in the deep future, there might be even stranger transformations waiting. And as we continue to drift through this cosmic meditation, as we settle deeper into contemplation of the ultimate fate of the universe, we are approaching the true culmination of our journey. We are approaching something that might be, in a sense, an answer to the question we began with. What happens after the last star dies? The answer unfolds across billions and trillions and septillions of years. It encompasses transformations so profound and so strange that they reshape our understanding of reality. And at the very end, in the deepest future, something almost unimaginable might await. As we continue this journey, we are moving beyond the reach of conventional physics. We are contemplating possibilities that exist at the very edge of what we can theorize about. We are approaching a realm where the laws we understand might no longer apply, where time itself becomes almost meaningless, where existence itself is transformed in ways that are almost impossible to describe. Let us now imagine that we have traveled so far into the future that the Iron Epoch is itself only a memory, and even that memory is ancient beyond comprehension. We have traveled a duodecillion years or more. We have passed through ages where white dwarfs decayed, where black holes evaporated, where protons themselves gradually transformed into lighter particles. We have drifted through a universe that became so vast, so dilute, so cold and dark, that nothing seemed to happen for spans of time that dwarfed the entire history of the current cosmos. And yet, something persists. Not the universe as we know it, not stars or planets or even atoms, but something more fundamental. The very fabric of reality itself, space-time, the quantum fields that underlie everything continues to exist. And in existing, it continues to change. And in changing, it continues to create possibilities that are almost unimaginable. One such possibility is the phenomenon we mentioned briefly before vacuum decay. In the deepest future, it becomes increasingly likely that the universe will undergo a phase transition, a fundamental change in its basic nature. The vacuum state might drop to a lower energy level. The laws of physics might change. And if this happens, the consequences would ripple across the entire universe. Picture this moment, if you can. The universe has been in the Iron Epoch for an incomprehensibly long time. Nothing has changed. Nothing has happened. The dispersion is nearly complete. And then, somewhere, in some pocket of space-time, a quantum fluctuation occurs that triggers something extraordinary. The vacuum decays. A bubble of new physics begins to expand. It spreads outward at the speed of light, transforming everything it touches. The laws of physics, the forces that hold reality together, everything changes. What happens after this transformation? No one knows for certain. The new physics might be gentle, transforming the universe into a different but still stable state. Or it might be catastrophic, causing the universe to collapse or expand so rapidly that everything is destroyed. Or it might be something else entirely, something that we cannot even imagine, because it violates the basic assumptions we make about how reality works. But let us consider another possibility, one that touches on something almost spiritual. What if, instead of a phase transition that changes the laws of physics, something else happens? What if there is a possibility, remote, theoretical, but possible, for the universe to eventually restart itself? What if, in the deepest future, after an incomprehensibly long time, the fundamental nature of reality might allow for something like a new Big Bang? This is not meant to be taken as literal religious metaphor, though it has an almost mystical quality to it. But in some theories of physics, particularly certain interpretations of quantum mechanics and general relativity, there is a possibility that the universe might be cyclical, that it might exist in patterns that repeat, that what we call the Big Bang might not be the beginning of everything, but rather a moment in a much larger cosmic cycle. If this is true, then the universe we are imagining, the universe of the far distant future where the last star has long since died, might itself be part of a pattern. It might be approaching a state where a new beginning is possible. The atoms that have decayed and reformed, and decayed again, might eventually, through processes we can barely understand, find a way to give birth to a new cosmos, a new universe with new stars, new galaxies, new possibilities. But for now, as we drift deeper into this meditation, let us not focus on such grand speculative possibilities. Instead, let us focus on what we know, or at least what we can theorize. In the deepest future, long after the last star has died, the universe will be a place of extreme age and extreme isolation. It will be a place of almost absolute cold and darkness. It will be a place where atoms are scattered so far apart that they are almost completely disconnected from one another. It will be a place where time itself, while still advancing, might seem almost meaningless, because nothing changes, nothing happens, everything remains in a state of profound stasis. And yet, in this darkness, something remarkable persists. Information persists. The structure of space-time persists. The laws of physics, whatever they might be at that point, persist. And perhaps, in ways that we cannot yet understand, consciousness, or something like it, might persist. We must be careful not to anthropomorphize or project human concepts onto the cosmos. But there is something almost profound about the fact that a universe created by the Big Bang might continue to exist, to evolve, to transform, long after it has become so old and so vast and so cold that it seems impossible that it could harbor anything recognizable as life or thought. Perhaps, in some sense, the universe's journey toward the Iron Epoch and beyond is not a journey toward death, but a journey toward transformation. A journey into states of being so alien and so strange that we cannot easily recognize them as alive or conscious or meaningful. And yet, they would be states that evolved naturally from the laws of physics, that emerged from the same cosmic force that created the stars and galaxies, and eventually, life itself. As you float here in the darkness of this meditation, understand that you are touching something almost sacred. You are contemplating the ultimate trajectory of existence. You are imagining a future so distant that it transcends the normal categories of thought. And in doing so, you are participating in one of humanity's oldest quests, the quest to understand the nature of reality, to comprehend our place in the cosmos, to explore what lies beyond the limits of normal understanding. The last star has died. It died billions of years before the times we are now imagining. The universe has aged beyond measure, and yet it continues. It continues to exist. It continues to evolve. And in the deepest future, in ages so distant that they are almost beyond comprehension, it will continue still. And now, as we approach the end of our journey, we arrive at a place that might be thought of as the true answer to our original question. What happens after the last star dies? After billions of years of aging, after the white dwarfs have cooled, after the black holes have evaporated, after the matter itself has decayed, what remains? What continues? What is the ultimate state toward which the universe is moving? The answer is almost paradoxical. Almost everything ends. The stars are gone. The planets are gone. The galaxies, as recognizable structures, are gone. The atoms themselves are gone, transformed into other particles, then perhaps transformed again. The universe has become dark and cold and almost unimaginably empty. And yet something persists, something continues. The universe itself continues. Imagine now that we have traveled so far into the future that time itself becomes almost abstract. We are no longer talking about days or years, or even trillions of years. We are talking about durations so long that the concept of time becomes almost meaningless. We are in what might be called the eternal future, the far end of the timeline where nothing more can happen, where everything that could change has already changed, where the universe has arrived at a state of final equilibrium. In this state, the universe is spread out to almost infinite thinness. The dispersion is nearly complete. What few atoms or particles remain are so far apart from each other that they have no chance of ever interacting. They exist in complete isolation, drifting apart forever, each one alone in its own region of space. The universe has become a realm of profound loneliness, a cosmos where every object, every particle, every remnant of what once was, floats alone in eternal silence. And this is where the universe might remain, forever and ever, if the vacuum remains stable, if the laws of physics never change, if the universe never undergoes a phase transition or a new Big Bang. Then this is the end state, the eternal rest, the silence that never ends. But as you contemplate this state, understand something profound. This is not nothingness. This is not annihilation. This is transformation. The matter that made up the stars still exists, though transformed. The energy that was released from stellar fusion still exists, though dispersed. The information encoded in the structure of the cosmos still exists, though scattered. Nothing has truly been lost. Everything has been converted into something else. And there is something almost beautiful about this endpoint. It is not a violent ending. It is not a collapse or an explosion. It is a gentle, slow, gradual transformation into a new state of being. The universe does not end with a bang. It ends with an infinite whisper. It ends with a fade into silence so complete and so eternal that it becomes indistinguishable from peace. Imagine yourself now floating in this ultimate future. Around you is darkness so complete that it is not darkness anymore. It is simply the absence of light, the natural state of space when no stars burn, when no radiation shines, when all the light that has ever been has faded into the infrared, into the microwave background, into wavelengths so long and so diffuse that they are essentially undetectable. You are floating in a universe of silence, a universe where nothing happens, a universe where time passes but nothing changes. And yet, even here, even in this state of apparent stasis, there is something. There is the structure of space-time itself. There are the quantum fields that underlie reality. There are the particles, however rare and scattered, that persist. There is the memory of everything that came before, encoded somewhere in the universe's structure, even if no observer exists to read it. The universe has arrived at its final state, but it has not ceased to exist. It has not ceased to be real. It has merely transformed into something almost unimaginably different from what it was before. In this silence, you might consider what it means to truly end. Does a star truly end when it becomes a white dwarf? Does the universe truly end when the last light fades? Does existence truly end when nothing observable remains? The answer, perhaps, is that ending is not absolute. Transformation is not the same as annihilation. The universe is not ending. It is changing. It is evolving. It is moving into states that we barely understand and can barely describe. And perhaps, in the deepest sense, this is what comes after the last star dies. Not nothingness, not the void, not some kind of cosmic catastrophe, but rather a gentle, slow transformation into something new. Something that has no light and no heat and no activity, but which is none the less real, none the less present, none the less eternal. As you rest here, floating in the comfort of this meditation, in the safety of your own awareness, understand that you have journeyed through the far future of the cosmos. You have witnessed the death of stars. You have seen the universe age beyond measure. You have explored the strange and beautiful transformation that takes place as everything moves toward its final state. And in doing so, you have touched something profound. You have contemplated the ultimate trajectory of reality. You have imagined the true endpoint of existence. The last star is dying, and as it dies, something else is being born. Not a new star, perhaps, but a new age, a new state of the cosmos, a new chapter in the endless story of the universe. The stars we see above us now, in the present age, will eventually end. The galaxies will eventually disperse. The atoms will eventually transform. But the universe will continue. It will continue for eternity. It will continue in silence and in darkness, and in a state that is almost unimaginably peaceful. And as we settle toward the end of our journey, as the meditation deepens and your mind becomes quieter and quieter, understand that you have been given a glimpse of something that few people ever contemplate. You have been shown a path through time and space that stretches from now into the infinite future. You have seen what lies beyond the death of the last star, beyond the cooling of the final white dwarf, beyond the evaporation of the last black hole. You have seen the peace that comes after all the light has faded, the silence that comes after all the noise has stopped, the eternal rest that waits at the end of everything. The universe is vast. Time is deep. The future stretches out almost infinitely far toward a destination that is beautiful in its strangeness and profound in its silence. And you, for this brief moment, have traveled there. You have floated through that distant realm. You have witnessed its majesty and its quietness. And as you return now, slowly, gently, from this cosmic journey, carry with you the knowledge that everything that is will eventually transform into something new. Everything that burns will eventually cool. Everything that is loud will eventually become silent. And in that silence, in that eternal peace, there is a truth about the nature of existence that transcends language, that transcends understanding, and that touches something deep within us. The last star dies, and the universe goes on, silent, eternal, peaceful. This is what comes after. This is the cosmic truth that we have explored together. And as you rest here, in the safety and comfort of this moment, as your breathing slows and your awareness drifts, hold this truth gently in your mind. The universe is beautiful. The future is vast. And peace, true and eternal peace, awaits at the end of everything. Close your eyes, if you haven't already. Let your breath become slow and gentle. Feel yourself drifting slowly, deeper and deeper, into the same silence that awaits the stars, into the same peace that will eventually come to all things. You are safe, you are comfortable, and you are part of this vast cosmic story, part of this journey through time and space and light and darkness. Rest now. Rest in the knowledge that you have contemplated something sacred, something true, something that connects you to the deepest mysteries of the universe. The last star is fading, and in its fading, something eternal is being born.